Okay, we got the 2021 WACE exam. Let's waste no time, let's just get started. Shows the complex number z and what is it? Determine the exact value for argument of negative z. So that would be negative z would be back here. And since this is pi on 3, we know that this angle here is going to be pi on 2, and this angle will be pi on 3. So it's going to be equal to negative pi on 2 plus pi on 3. And this will be equal to negative, make it 6, 3, 4, 2 pi on 3. What would it be? Let's see. This angle here will be pi on 3. Pi negative pi minus pi on 3. Yeah, negative 2 pi on 3. Okay, and then the magnitude of z plus 2 is 1, and this angle here would be, so this is the magnitude of z plus 2, 2 and 1. This angle here will be pi on 6. Up by 1, and then here cis of pi on 3. So z is equal to cis of pi on 3. Could be a half plus square root of 3 on 2. 2i. So then z plus 2 is going to be 5 on 2 plus square root of 3 on 2i. And the magnitude of z plus 2 is going to equal square root of 25 on 4 plus 3 on 4. So it would be square root of 28 on 2. Or divided by 4, bring the 2 out, so square root of 7. Okay. I think that's correct. Square root of 7, 4, square root of 7, 2. Yep. Okay, sketch the function f of negative 1 on the same axis used for the function f of x. So let's do our 45-degree buddy here. So we need to reflect it across that guy. For function f. So 3, 2, let's go 2, 3. It crosses at 2, 0, so we go 0, 2. It then goes through 0, negative 1.5, so we go to negative 1.50. And negative 1, negative 2, negative 2, negative 1. So it's going to look like that. Explain why the inverse of g is not a function. G of x is not 1-to-1. So g negative 1 of x will not be a function, because it would be 1-to-many. Because if I said like 3, yeah, as it would be will be many to 1. Oh no, sorry, 1 to many. Okay, and the defining rule for that, determine the defining rule for yf of negative x. So then we'll say that x is equal to 2 minus 2 square root of 3 minus x minus y. So then we have that 2 square root of 3 minus y is going to equal 2 minus x. Divided all by 2, we have that 3 minus y is going to equal 1 minus x on 2. So we have 3 minus y is going to equal 1 minus x on 2 squared. So then y is going to equal 3 minus 1 minus x on 2 squared. Three, 0, minus 1, 4.5. So negative 2, 2, 4. Okay. And then let's say, given that, so the range of f of x is negative 2 to 2, so we'll say given that x is a part of the reals such that negative 2, that's going to equal to x, that's going to equal to 2. So negative 1.5. Five, 3 on 4. Equals 0. Wait, so we go 0, negative 1.5, negative 1.5, 0. All the other points work except for that point. Why does this point not want to work for me? Three 3.5 over 2. Zero. Negative 1.5 and 0. Why does that point not want to work? Everything else works. 2, if you sub in 2, that. But I can't sub in this, negative 1.5. 1 plus 1.5 all over 2 squared. .5 over 2 is 4 squared. I have no idea. Right, so if I did 0, then 3 equals 1 plus. It's this point. Because that's definitely, I'm not being stupid, right? 0, negative 1.5. So negative 1.5 is 0. Okay, whatever, we'll come back to it. Determine the exact value of g of f of 0. So let's say f of 0 is equal to f of 0 is negative 1.5. G of negative 1.5 is equal to, so negative 1.5 is 2.5. Determine the domain for the function f of g of x. Justify my answer. F of g of x. So let's see, domain of x is equal to negative 2 to 2. So x is equal to 2, and then the range of that is equal to 0 to 4. Domain of f of x is equal to negative 2 to 2. Therefore, we need to restrict range of g of x to 0 less than or equal to 1 less than or equal to 2. Therefore, domain g of x is going to equal, because it can't go to 4, so we're going to have x equals x is going to equal, so x is a part of the reals such that x has to be from 1 to 2, or x equals negative 2. 1 less than or equal to x less than or equal to 2, or x equals negative 2. Oh wait, no, 2, 3 goes up to 3. To 3, not to 2. So 3, it is 0.5. So I'm going to have negative 2 to negative 1. Okay, let's redo this. So negative 2 less than or equal to x less than or equal to negative 1, or 0.5 less than or equal to x less than or equal to 0. Wait, no. 3 to 2. Because I needed to restrict my domain to that. Okay. Why can I not sub in this point here? Negative 1.5. 2 minus 2 squared root of 1.5. So 4.5 equals I have no idea. Oh wait, no, minus 0. It's 2 squared 3. 0. That is so weird. Oh, because it's from negative 1 to 3. Wait, no, that's fine. So this should be negative 1. Okay, whatever. So the domain of that is -1 to 3. Yep. Let's just continue. How many questions are there? Okay, there's quite a few. It's 13 pages to go. Using the appropriate substitution, determine the exact value for 15x. Let's say that let u equal, let's say, square root of x minus 2. And du dx is going to equal 1 on 2 square root of x minus 2 I don't think this is going to work. What if we just say x minus 2? Then du dx is just going to equal x minus, it's just going to equal 1, sorry. So then du is going to equal dx. And then here we can say that u plus 2 is going to equal x. And then when x is equal to 3, u equals 1. When x equals 2, u equals 0. And here we're going to have 1 to 0 of 15 of u plus 2 square root of u du. This looks a bit more manageable. 1 to 0. So this is 15u to the power of 3 on 2 plus 30 u to the half du. And then this is going to be so it's going to be 30 on 5 u to the power of 5 on 2 plus 60 on 3 u to the power of 3 on 2 from 1 to 0. And then this is going to be 6u to the power of 5 on 2 plus 20u to the power of 3 on 2 from 1 to 0. So then this is going to be 6 plus 20, and then 0 to the power of anything is 0. 0, so then this will be 26. I am pretty sure. So you will be 15 outside of 2 on 5u, 5 on 2 plus 2, so then 4 on 3u, 3 on 2. It's going to equal 6 plus 20 on 15, 26, yeah, okay. Consider the function that, which is okay. Sketch the function, indicate clearly the x and y intercepts in any asymptote. So we're going to have an asymptote of x minus 1, x minus 1, so minus 1, and we have this like this. Oh, that was a bit off. Wait, this graph paper just isn't. Bro, I don't think this graph paper is just very good. Okay, I'm not going to draw with that then. Let's do it like this. So y equals x minus 1. Clearly the x and y asymptotes in any intercept. So then when y equals 0, I have 0 is equal to x power 4, x squared minus 4 on x plus 1. X is going to be, I'll just say 0. So x squared equals 4. X is plus or minus 2. So we're going to have that there and that there. And then when x is equal to 0, y is going to be equal to negative 4 on 1, so negative 4. So 0, negative 4. Then we have to find our turning points. So we have dash of x is going to equal the derivative of the top, which is going to be 2x on x plus 1 minus 1 of the top, which is going to be x squared, so minus x squared plus 4 on x plus 1 squared. So this would be 2x squared plus 2x minus x squared plus 4 on x plus 1 squared. This is x squared plus 2x plus 4 on x plus 1 squared. If we let that equal 0, we have 0 is equal to x squared plus 2x plus 4, which is going to be, did I do something wrong? The root of the top, just 2x times x plus 1 minus 1. What's that? X squared 2x. Plus 1 squared plus 3. There's no turning points. No real solution. Therefore, no turning points. Okay. When x is less than negative 1, I'm going to have to follow it like that. No solutions to this. Clearly indicate the x and y intersect with any asymptotes. Oh wait, there's going to be an asymptote at x equals negative 1. So it would be just something like that. Something like that. Okay, I think that's a bit better. Sketch the graph. And then this is x equals negative 1. So asymptote x minus 1. If it's on the left hand side and this is minus 1, then this bit becomes negative, so then this becomes above the x-axis. Yep. Okay, pretty happy with all of this then. So let's label these points, negative 2, 0. This would be 2, 0, and then this is negative 0, negative 4. No real solution, therefore no turning points. Kidoki. And then x plus 1 equals 0. X cannot equal negative 1. Nice. 8. Given that all of that, determine the values of a and b. So we want that 7x squared minus 12x plus 2. It's going to be ax squared plus 2 plus bx of x minus 2. So let's say let x equals 0. Then what we're going to get is 2 is going to equal 2a, and that b is going to disappear, so a is going to equal 1. And then we'll look at the x squared coefficient. We have that 7x squared is going to equal x squared plus bx squared, so then b is going to equal 6. If you got a constant, 6 minus 2, yada yada yada. Yep, so then therefore this is the same as 1 on x minus 2 plus 6x on x squared plus 2. Oh wait, no, that's correct. X squared plus 2. Because when I cross multiply, then the x minus 2 will be that one, and x squared. Okay. And then 2 x squared minus 12x. Hence determine this. So this is going to equal 1 on x minus 2 plus 6 on x squared plus 2 dx, or 6x minus 2, 6 plus 2, yep. So then there's going to be ln of x minus 2 plus the derivative of this is just going to be 2, so we're going to need 3 lots of ln x squared plus 2 and plus c. Consider the quartic polynomial. Given that that is 0, determine a quadratic factor of p. So real coefficients. So real coefficients, therefore 2 minus 4i also a factor. So then, so we'll say z minus 2 minus 4i is a factor. So factor and real coefficients, therefore z minus 2 plus 4i is also a factor. Therefore it's z minus 2 minus 4i and z minus 2 plus 4i is going to equal z squared minus 2z plus 4zi minus 2z plus 4 minus 8i, then minus 4zi 4zi plus 8i, then negative 16, then I squared, so plus 16. So that will cancel, these will cancel. So this is z squared minus 4z plus 20. Z minus 2 squared plus 416, 4i, yep. Hence solve the equation of that. So then this is equal to z squared minus 4z plus 20 of z squared plus az plus b is going to equal p of z. And we know that 20b is going to equal 60, so then b equals 3. And then we have that negative 4z to the power of 3 plus az to the power of 3 equals negative 6z to the power of 3. So then a must be equal to negative 2. Let's see if that all adds up. So negative 4z, negative 2 is 8. So 8z squared, we're gonna have 20z squared, 3z squared. Yep. 52z. Negative 12. And negative 40, negative 52. Yep. Okay, so then therefore 1z plus 20 equals 0. If we'll say if p of z equals 0, we have that z squared minus 4z plus 20 equals 0. Z is going to equal 2 plus or minus 4i, or z squared minus 2z plus 3 equals 0. And z minus 1 squared plus 2 equals 0, so then z is going to equal 1 plus or minus square root of 2i. Put that in minus 1, negative 2, negative 2. Yep, okay. Complex number, or the number 2021 can be expressed as a product of two consecutive primes. Consider the equation z to the 43. Write an expression for the roots of z43 equals 1. Z is equal to cis of 2 pi k on 43, given that k is equal to 0, 1, 2, 42, 43. Let w be any one of the roots. How many of these roots will also be a solution to the equation z to the 47 equals 1? So z to 47, z will equal cis of 2 pi k on 47, given that k equals 0, 1, 2, 46, 47. So what we need is that 2 pi k on 47, 2 pi k on 43. Would this be true for anything? Any of the roots of the equation. Because they have no primes. As these are as 47 and 43 are prime. They share no common factors. Thus, the above is only true for k equals 0. Therefore, only one solution. Only one root will be shared. Because there are no factors, then this will be true for any of them. So it'll be irreducible. No common factors other than 1. Yes, they will be irreducible. Otherwise, the fractions will be as the denominator will never change. Seven given k. And one will be shared. Okay. The heart-shaped figure is given in the equation. Oh god. For this 0, the equation becomes that. Equals 2. This heart shape is a special property that for each x coordinate in this domain, its two y coordinates are an equal vertical distance from the curve. Okay. Explain why the domain given by that equals 2 is 0 less than or equal to. For square root of x, x has to be greater than or equal to 0. And for x squared, for let's say x greater than or equal to square root of 2, 2 plus y minus square root of x squared equal to 2. Thus, this will need to be y minus square root of x squared has to be less than 0, such that x squared plus y minus square root of x squared equals 2, but is any n squared to be greater than 0? This is impossible. Therefore, x has to be less than or equal to square root of 2. Show that the total area enclosed by the heart-shaped figure is given by that 2. So we want it in terms of y. So let's say x squared plus y plus or y minus square root of x squared equals 2. So then this is x squared plus y squared minus 2y square root of x plus x equals 2. So x squared plus y of y minus 2 square root of x plus x equal to 2. This doesn't really help. I'm going to take out factor square root of x. That won't help either. 0 to 2. 0 to square root of 2. Has something to do with the y equals square root of x thing. Let's do y squared minus 2y square root of x is equal to 2 minus x squared. Minus y minus y is equal to distance is equal distance to square root of x. Y equals square root of x, and that's y squared minus 2 minus x I think I'm just going to write that from now. So y minus x 2 minus x squared. So then y is equal to 2 minus x squared. So then area is equal to 2 times 2. 0 square root of 2 of square root of 2 minus x squared dx. So then 4 square root of 2, 0, 2 minus x squared dx. Okay, 6 minutes left. Use the substitution x equals, right? So then x is equal to, actually let's write the full thing. Square root of 2 square root of 2 minus x squared dx. Let x equals square root of 2 sine of theta. Then dx d theta is going to equal square root of 2 cosine of theta. So dx is square root of 2 cosine of theta d theta. When x is equal to square root of 2, sine of theta is going to equal pi on 2. When x is equal to 0, theta is equal to 0. Therefore our area is going to equal 4 pi on 2 to 0 square root of 2 minus 2 sine squared of theta, and then here we're going to have cosine of theta d theta, oh wait no, square root of 2. So this is going to equal 4 square root of 2 pi on 2 to 0. Actually, let's make this 8. Because I'll bring this square root of 2 factor out of here, and then we also have a square root of 2, so times 2. So 8 cosine of theta squared d theta, which will be 4 pi on 2, 0, 1 plus cosine of 2 theta, d theta. This will be theta plus 1 on 2 sine of theta, pi of 2 theta, from pi on 2 to 0, which would be 4 of pi on 2 plus 0 plus 0 and 0. So this is just going to be 2 pi units squared. Okay. Pi. Okay, yep. Pretty happy with that. But this, I'm not very happy with. Show that the total area enclosed by the heart-shaped figure is given by. So it definitely has to do with symmetry, because there's 4. Wait, that's the end of the question. Yeah, okay. So maybe this area is going to equal this area. I don't know what y squared of there would be. Y minus square root of x. Y squared minus 2y square root of x plus x is equal to 2. Negative x squared is equal to that. Y squared. Maybe it's y minus root of x squared is equal to 2 minus x squared. Oh yes, it's that. Okay, wait. Okay, I have a minute. Okay, so area. So I have x squared plus y minus square root of x squared is equal to 2. Y minus square root of x squared is equal to 2 minus x squared. So y is equal to square root of 2 minus x squared plus square root of x. So then area is going to equal 2 times 2 minus x squared plus square root of x minus square root of x dx. So area is going to equal 4 of 0 to square root of 2 minus x squared dx. Woo! 30 seconds left. Wow, if I was in an exam, I would be pooping my pants right now. Yeah, because they're equidistant, we can say that the areas are the same above and below. And then we want to take away the area of this y squared. So I say here, area above y equals square root of x is the same as below. Oh, that scared me. Okay. We're gonna do calculator assumed when I come back, because we're gonna go for a little bit and then we're gonna come back. So yeah, see you in a second. All right, time to do 2021 calculator assumed. See how many pages we got to go through. 2021 22 pages, okay. So, let's get started. Beam light completes 3 revolutions each minute from a lighthouse that is 50 meters from the coastline. Determine the speed of the beam moving across the line when it is at P, 100 meters up the coast, correct to the nearest, 0.1 meters per second. Data. So, the theta dt, it completes 3 revolutions each minute. So it completes a revolution every 20 seconds, so it'll be 2 pi on 20. So pi on 10 radians per second. Determine the speed, so you want dx dt. So this would be probably dx d theta, and then d theta dt. Now x is going to equal, so let's see, tan of theta is going to equal x on 50. So then x is going to equal 50 tan of theta. And we have that dx d theta is going to equal 50 secant squared of theta. And then at x equal 100, tan theta equals, so I need to solve for half is equal to theta. So 0.5 equals tan of x. Is there a standard of this? Nope. So theta equals 0.4636. Therefore, dx dt is going to equal 50 secant squared of 0.4636 times pi on 10. Because if you do it 60 seconds, then that's 6 pi, which is 3 revolutions. Yep. So this is going to be 50 times 50 on 1 of cosine 0.4636 squared times pi divided by 10. Dx dt is 19 point, yes, so 63 meters per second. Because secant is 1 cosine squared. So, yep. Okay, the part of the slope field is given like that. Calculate and draw the slope field at the point 0.5 negative 1. So at 0.5 negative 1 dy dx is going to equal, so x minus 1, so 0.5 minus 1 all over 2y, so 2 times negative 1. This is going to be negative 0.5 on negative 2, or it'll be 1 on 4. So a gradient of 1 on 4 it just has to draw the slope field. So 1 on 4 will be something like this. Maybe. Determine the equation of the solution curve that contains the point 0, 0.5. So dy dx is equal to x minus 1 on 2y. So we have here 2y dy cross multiply equals x minus 1 dx. So we have that y squared is going to equal x squared on 2 minus x plus c. And then let's sub in 0 and 0.5. So we have that 1 on 4 is going to equal, all of that will be c. So then y squared is going to equal x squared on 2 minus x plus 4. This is determined. Draw the solution curve that contains the point. So let's see, y squared, x squared minus x 0, 0.5 y squared. When does this equal 0? So let's say 0 equals x squared on 2 minus x, sorry Duolingo, plus 1 on 4, and hold on, we're going to pause because I need to do, my time is on, so I'll be back. And we're back. Okay, so let's solve this. So then solve x squared divided by 2 minus x plus 1 divided by 4. Equals 0. X is going to be, x is equal to 1 plus or minus 2 on 2, which is equal to 0.293 or 1.707. What the heck? If I follow the slope field, like here, it's going to go something like that. Wait, hold on. What if I just do this on my CAS? Interactive differential calculus. No? Differential equation graph? Okay, yes. So dy dx is going to be x minus 1 on 2y. And initial condition, let's set this to the 0, 0.5. And then graph. See, this side goes off like that. And then we come in at about 0.29, so 0.3. And this is about 2.5, so it'll be about there. Solution curve that contains the point. Okay. 0.5 negative 1. Do I include this bit up here, where it's 1.7? And I go for that. Not sure. So I assume it'd be something like that. The CAS doesn't want to do it, but it contains the point 0.5, 0. It's just equation of the solution curve. So do I do y squared or do I do y? I guess maybe it's not continuous, so I don't continue. Not sure. Okay, I'm just going to continue. Two complex numbers z1 and z2 are shown on the eigen diagram below. Write an expression for z1 in exact polar form. So the magnitude is going to be 2. So 2 cis of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 on 12 is going to be 5 pi on 6. Our next expression for Z1 in exact Cartesian form. So Z1 is going to equal 2 cis of negative. So negative square root of 3 plus 2 is 30, so 1i. So 3 plus i. Let me see if that is correct. 2 cis of 5 pi divided by 6 on my calculator. Yep, let it be complex. So negative square root of 3 plus I. Plot the complex number IZ2 in the Argand diagram below. So I need to move this up by 90 degrees. So if it's 90 degrees, and 1, 2, 3, 4, 5, 6. I need to move it 6 up. So I go 1, 2, 3, 4, 5, 6. So it'll be up to here. So this will be I, Z2. And you move it anti-clockwise. So yes. Okay, a sketch on the locus or complex number is shown below. The upper boundaries of the locus is part of a circle. Center Z equals I in terms of Z without using for the indicated locus. Okay. So let's say that argument of 1. So it's that 5 pi. So 5 pi on 6. Actually, wait, the lowest argument is going to be 1, 2. So pi on 6 is less than or equal to argument from the origin. So 5 pi on 6. And then we need that the magnitude of Z minus I, because we're going from I, is less than or equal to 2. Okay, so let's write this up here. So and magnitude of Z of I is less than or equal to 2. Okie dokie. The horizontal displacement of a Ferris wheel can exhibit harmonic motion. The maximum horizontal speed is pi over 2 meters per second, and the period is exactly 60 seconds. So let A cosine nt be the horizontal displacement after t seconds. Okay. Period of its motion is exactly 60 seconds. So period. So 60 is equal to 2 pi all over n. So then n is equal to pi 30. And then V max is going to equal the absolute value of Ka n a, so it's going to be the maximum horizontal speed is pi on 2 is equal to pi of 30 and a, so a is equal to 15. So then x of t is equal to 15 cosine of pi on 30 t. Okay. Determine the horizontal acceleration, correct, when the horizontal displacement is 10 meters. So acceleration of t is going to be equal to negative n squared of x of t. This will be negative pi squared on 900. And then this will be here. Just be 15 cosine of pi on 30 t. Oh no, so x. So then a of t. Let's just do acceleration constant. And then let's say when x is equal to 10, acceleration is equal to negative pi squared on 90 is equal to negative pi squared on 90. So negative 0.1010 meters per second. 3 decimal places. Wait, hold on, I did this wrong. 3 decimal places would be 101 meters per second. We want it to be n squared, so k, yep. Okay, a solid spherical cup with a depth of h is part of a solid sphere with a radius of 10 centimeters. This cup can be generated by revolving the shaded region around x-axis. Show that the equation for the circle above is 20x. So center at 10, 0 with radius equaling 10. Therefore, x minus 10 squared plus y squared equals 100. So then x squared minus 20x plus 100 is y squared equals 100. X squared plus y squared equals 20x. Derive an expression for the volume of the spherical cap in terms of h. So your volume is going to be equal to AB. In this case, since we're revolving around the x-axis, we want y squared. So y squared dx is when you're revolving around the y-axis. Just make sure I get this right. About the x-axis on y squared. Yep. So then, since we have x squared plus y squared equals 20x, we can say that y squared is equal to 20x minus x squared. So then volume is equal to pi, and we're going to go from 0 to h of 20x minus x squared dx. This cap can be generated by revolving the shaded region by the x-axis. Okie dokie. On a Saturday afternoon, 3 separate families visit their local cinema to watch a feature movie. The cinema names this as Dollar Day, where the ticket prices for adults, children, and pensioners are charged in whole dollar amounts. The table below indicates the number of people in each category and the total paid for each family group. Okay. For each family group. Formally, the equations are used to determine the ticket prices. Okay, so then we have, I spat on my iPad, 2a plus 4c equals 108, 3a plus 6c equals 162, and then 2a plus 5c plus 2p is equal to 152. So then solving simul on CAS. Or solving above simultaneously on CAS. We're gonna have 2x plus 4y equals 108, 3x plus 6y equals 162, and then 2a plus 5y plus 2z is going to equal 152. X, y, and z. getting some weird results. I have 3 unknowns. Why are you not solving nicely? Why is it giving me z equals z? Huh? Well, if I do this with just x and y, so that one and that one, give me x and y. What is this? System. Algebra. Decimal. Complex. Wait, what? Why? What the? Edit, clear all variables. Why is it? Oh, okay. So I have to solve these individually, it seems. So 2a plus 4c equals 108. 3a plus 6c equals 162. So let's do this as 6a plus 12c. So 108 times 3 is 324. And this can be 6a plus never mind. Wait, oh, I'm so stupid. Okay. So let's do equation 2, equation 3. Okay, we'll do equation 3 minus equation 1. Aha! Then this becomes, so the a's cancel, well, 1c and 2p left. So this is going to be c plus 2p equals 152 minus 108. 44. Okay, there we go. So confused because they must be. These two must just be like scalar multiples of each other. Yeah. Oh, yeah, they are. They're 50% of each other. I think 54. Yeah. Okay. The equations, formula in part A. So I'll say on CAS. Simul. We'll do 2a plus 4c equals 108. And we'll do 2a plus 5c plus 2p equals 152. Then we'll do c plus 2p equals 44. Okay, this hopefully should 4y equals 108 should give us a good answer. 152, and then x, y plus 2z is 44. I'm still not getting nice answers. If I add another one, so then I go 3x plus 6y equals 162. Nope, still not going to give me an answer. I gonna do this? Okay, let's say that 2a equals 108 minus 4c, and 2p equals 44 minus c. So if we take this, so therefore equation 2, this becomes 108 minus 4c. Oh, is this just gonna cancel out? No, it is. What? What on earth? X plus 2z equals 44. If I did this as matrices, so 2, 4, 0 is 108. 252 is 152, and then 3a6 or 360 is 162. No, because that's just going to cancel that out. So we'll say R. We'll say P equals P, or let P equals lambda. C is equal to 44 minus 2 lambda, and then X is equal to 4 lambda minus 34. I think that's what they must be doing. P equal P. I don't know. That's 34. Okay, I'm just going to leave it like that. Explain the geometric interpretation of equations and the simultaneous equation. So since there are infinite solutions, 3 planes that intersect so these two planes are parallel to each other. You know, they're overlapping, so 2 planes overlapping with one that intersects them. 2 overlapping planes as equation 2 equals 1.5 equation 1. You have 2 overlapping lanes with a 3rd plane intersecting these two along an infinite line, thus infinite solutions. Two overlapping parallel planes. This 2 element infinite line. Now assume that the price for an adult is greater than the price for a child. And the price for a pensioner is the lowest price ticket. So the price for an adult is greater than the price for a child. So then an adult was 4 lambda minus 34 was greater than 44 minus 2 lambda. And the price for the pensioner is the lowest price ticket, which was less than lambda. So let's solve this. We have 6 lambda will be greater than 78. So then lambda is less than 13. It's greater than 13. And the pensioner is the lowest price ticket. So lambda is the smallest. Let me see if I solve it. 4x minus 34 is to be greater than 44 minus 2x. X is greater than 13. Then if we have c plus 2 lambda being equal to 44, and lambda equal 14, c then is going to equal 16. Which checks with c greater than lambda. And we need that a dot greater than lambda, which is also just p. So then 44 minus 28 is 16. 16, well, c equals 16. Check with 2a plus 5c plus 2p equals 152. Don't equal, so solve 2x plus 5 times 16 plus 2 times 14 equals 152. And then this checks with a greater than c greater than lambda. And then I'll say if lambda equals 15, c would equal 14, but c greater than lambda, therefore only solution is that lambda must equal 14, p equals lambda which equals 14, child equals 16, and an adult equals 22. Okay, Jesus Christ, that was terrible. An experiment was conducted to measure how quickly adults respond to requests sent in a text message. T code the numbers of hours taken for an adult to respond and send a text message. It was found that the distribution of the population response was given by the probability density function with a mean and a standard deviation of 24. Random samples of 64 were drawn repeatedly from the population of response times, and the sample mean was determined for each sample. The probability of the sample mean response time would be between that and that. So the standard deviation of that is going to be 2.4 all over square root of 64. So 2.4 over 8. So 0.3, and then u of t dash is still going to be 3 hours. Let's move, yeah, we'll change this on to minutes, I think. Never mind. So 3, so this is hours, this is hours. Require probability of, or actually let's say t is approximately normal distribution with 3 and 0.3 squared. Require that probability of 150 is going to be 2.5 hours, so 2.5 less than or equal to t. And then 210 is going to be 3.5. 60 is 3.5, which is equal to normal CDF of 2.5 to 3.5 of 0.3 and 3 is equal to 3 and 3, 0.9044. 0.9044. Okay. This probability sketch the likely distribution of the sample mean t on the axis below. Okay, so we want it to be centered on 3. What if I just have it like really close to 3, like 3.9 to 3.1, 26. 990. Wait, what is this graph? What is y? Is y the... So if I did 0.2, 0.1... Oh wait. And then my standard deviation was what? 0.3, right? So that means that at about 2 equals 3 times 0.3 is 0.9. So 2.1, we should already have 99% of my distribution. Very, very small like here. And then this side will just be like continuing on from there. Like that. Okay, Annika, a teacher theorized that as teenagers tend to check their text messages more frequently than adults, and the population mean response time for teenagers will be much lower than the adult one. Annika is percent of the sample mean response for a sample gathered from an unknown source. Calculations are performed, and Arnica concludes by stating the sample was clearly not taken from the population of adult. Highlight here was taken from a sample of 100 teenagers. Perform the necessary calculations and comment on Arnica's claim. So then, sample standard deviation. So let's say sample mean. So let's say the mean standard deviation is 2.7 over square root of 100. So that is equal to 2.7 over 10, which would be 0.27. And then the sample mean was going to be, so mean is going to be 2.1. So let's get a sample. So let's get a margin of error. Let's say 95% confidence interval. Therefore, we'll have k 6. So then margin of error. So you could have 1.96 times 0.27, which is 0.5292. Therefore, it's going to have 2.1 minus 0.5292, 1.5708, less than or equal to mu, less than or equal to 2.6292. However, as 3 lies outside, or mu equals 3 lies outside of this 95% confidence interval, but as not all confidence intervals will contain the true value of mu. It is not enough evidence. I think in specialists, if it's not in the interval, we say it's still not enough evidence. Not enough evidence to suggest that this population was of teenagers. Teenagers rather than adults. But as not all confidence intervals, potential value of mu, and I'll say here only 95% will. There's not enough evidence. Okay, a rectangular prism is defined using the coordinate system with A. C and T, point M is the center of the planar face OC. FT. Okay. Determine the vector equation for the prism's main diagonal, which is B to T. So B to T is equal to BA plus AO plus O to T, which is equal to, so BA is negative C, C and then minus A plus T. So this is going to be negative 0, 0, wait, negative 0, 4, 0 minus 2, 0, 0 and 0, 0, 3 plus 0, 0, 3. So this is equal to negative 2, negative 4, and 3. Determine the Cartesian equation for the sphere that contains all vertices of the rectangular prism. So the center will be at M, and then it's halfway OC, or OA I mean. Center at O M, wait, what was it? OCFT plus half of C. Actually, no, this is M. Plus half of C, which is OM plus half of C, which is 0 to 1.5 plus half of, now C was 0, 4, 0. So this is 0, 4, 1.5. And then radius is equal to let's take some point T, so 0, 0, 3, so it's OT minus OM should be equal to 0, 0, 3 minus absolute radius is going to be that minus 0, 4, 1.5, and this is 0, -4, 1.5. And this is square root of -4 squared plus 3 on 2 squared. So 16 plus 9 on 4, that's 64, so square root of 75 on 4. That's 5 times 5 on 25 times 3, that's 5 on 3. 5 square root of 3 on 2. Therefore, I believe I'm going correct. The center of the planar surface. And then we go, oh no, I don't want OC. Damn it, I want OA. Plus half of A. God damn it, so 200. 200. So this is 1, 2. And then I want OT. So to get to the center, we go from here to O, and then up to T. Okay, and also this is an O to M, this would be O to C. T minus the center, which is 1 to 1.5. So then this is all 1 to 1.5. Okay. So -1, -2. I'm just going to do this in a calculator. So vector normal. I want -1, -2, 1.5. As a, no, not as a decimal, it's a standard. So square root of 29 on 2. Therefore, we have that x minus 1 squared plus y minus 2 squared plus z minus 1.5 squared. (1.5 squared) equals the radius squared. It's going to be 29 on 4. Prove using a vector method that line AM does not intersect BT. BT. So let's say BT line from BT is going to be, so say R equals, now B is O to B is 0 to 240. Plus, let's say lambda of, now B of T was -2, -4, 3. Line from A to M, so R is equal to so let's say A is 200 plus, let's say mu of AM. Now A to M is going to equal OM minus A, which is going to be -2 to 1.5. Therefore, RAM is equal to 200 plus mu of -2 to 1.5. I component. So we need that 2, -2. So we'll say if intersect I component 2 minus 2 lambda is going to equal 2 minus 2 mu. And then j component, which is going to be 4 minus 4 lambda, is going to equal 0 plus 2 mu. Cast simul, lambda is equal to 2 minus 2x equals 2 minus 2y. 4 minus 4x equals 2y, x and y. Lambda is equal to 2 on 3, and then mu is equal to 2 on 3 as well. Then k component, or z component, wait, k component, 3 lambda equals 1.5 mu. So 3 of 2 on 3 equals 1.5 of 2 on 3. So then 2 does not equal. So this is 3 on 2. 2 does not equal, and therefore do not intersect. Equations of beta A, which is going to be negative C, negative A, and T. And B is 2, 4. Oh, AM is going to be negative 2, negative 2, 2, 1.5. Okay, so then 2 minus 2 lambda, 4 minus 4 lambda, 2 minus 2 mu, 2 mu, 3 times 2 minus 3, and 1.5 times 2 divided by 3. Yep. Okay, so 16. A researcher is interested in estimating population mean residents has spent online via shopping in December 2020. Give a sample mean of 400, a sample deviation, and a confidence width of $200. So then this would be 200 less than or equal to mu less than or equal to 600. 95% confidence interval of width. Oh wait, width $200. So which would be $100 on each side. So 300 mu less than or equal to 500. Calculate the standard deviation of the sample mean, correct at $0.1. So we have the margin of error equals 100. And k equals 1.96 for 95% confidence. Therefore, 100 equals 1.96. So that's going to equal 100 divided by 1.96, which is $51.02. In terms of n, what sample size would you with a width of $50? Show your reasoning. With a width of $50, so with the width of $50 equals the margin of error equals 25. So 25 is going to equal 1.96 lambda mu I will say, how should I do this? Lambda on square root of n1, or let's say x n1, where lambda on square root of n1 equals 51.02. Therefore 25 equals 1.96 of 51.02, all on square root of x. X is going to equal 16.00, therefore 16n. What is the probability that this another sample size of 2n will produce a sample mean that differs from that another sample size 2n will produce a sample mean differs by more than $50. So then it's going to equal 51.02 all over square root of 2. So 51.02 divided by square root of 2 is 36.08. Therefore, let x be a normal distribution where our sample mean was 400, and then our mean is squared. So then probability of 350 would produce a sample mean that differs by more than, and therefore require one minus the probability that is within that, so 350 less than or equal to x less than or equal to 450, which is equal to 1 minus, so normal CDF of 350, 450 of 36.08 of 400, 0.83419, 83419, which is to 42. So 0.1658. 4 different confidence intervals are obtained from the mean amount spent via online shopping by per resident since December 2020. Which of the confidence intervals contains here the population mean? Undecidable or cannot be determined. Due to inherent nature of random sampling. It is not certain that any of these confidence intervals contain mu. Okay, for each state the confidence intervals that has the smaller width, so A or B. So we'll say A because it has a smaller A has less confidence. So confidence level is lower. And then C and D. Sample size. So confidence level is the same. So for C, margin of error is going to equal 1.96. sample standard deviation. S on square root of 2 times divided by square root of 2, so 0.386. So then for D, margin of error is going to equal 1.96.8 on square root of 1. So 1.96 times 0.8 is 1.568. Actually, wait, let's do this. Square root of 2n. So this would be s on square root of n. And for D, margin of error equal 1.96 of 0.8s over square root of n. So then this was 1.568s on square root of n as the margin of error is smaller. D will have smaller width. Confidence level is lower, then I'll say thus margin of error smaller, thus interval is smallest. I feel like there's been a lot of stats in this exam. Ah, there we go. The equation 3, okay, whatever, implicitly defines the curve shown below. Use implicit differentiation to obtain an expression for dy dx. So I'm going to rewrite the expression down here. As y to the power of 3 equals 3x1 plus y. So this is going to be 3x squared plus 3y squared dy dx is going to equal 3y plus 3x dy dx plus dy dx. So let's move everything to the right, or the dy's to the right. So this will be 3x squared minus 3y is going to equal 3, I'll say dy d. So dy dx on 3x plus 1 minus 3y squared. So dy dx is going to equal 3x squared minus 3y on 3x plus 1 x plus 1 minus 3y. Okay, let's see if this is the same that we get. So calculation implicitly differentiate x to the power of 3 plus y to the power of 3 equals 3xy plus y. 3 x squared plus y 3y squared plus 3x plus 1 minus 3y squared. Okay, yep. The slope of the curve at the origin and points A and B are 0. Show that the equation that determines the x coordinates of point A and B is given by that, and hence determine the coordinates for point A correct to 0.001. A, B, and 0 is equal to 0. Slope of the curve at the origin. So let's say dy dx is equal to 0. Then we have that 3x squared minus 3y all over 3x plus 1 minus 3y squared. I'm just looking at my CAS calculator right now. So this will be equal to 0. Determines the x coordinates for points A and B is given by that. So if that's all equal to 0, then x squared, 3x squared minus 3y equals to 0. So then x squared equals y. I'm going to sub it back into this equation. So x plus y to the power of 3 plus 3xy minus y plus y. So this is going to be x to the power of 3 plus x to the power of 6 is equal to 3x to the power of 3 plus x squared. So then this is going to be x to the power of 6 minus 2 x to the power of 3 minus x squared is equal to 0. Yep, this looks like what we need. So then x to the power of 4 minus 2x minus 1 is equal to 0. Nice. Okay, I'm cooking. Now my CAS, x is equal to, so solve x to the power of 4 minus 2x minus 1 equals 0. So it's negative 0.475 and 1.395. When x equals negative 0.475, y equals, so let's put this in here. Let's do solve, and so 0.475 plus here negative 0.475, given that I want value of y. So y is equal to 0.22, is that what it looks like? So negative, yeah, I think that's what it should be. So negative 0.225, therefore we're going to have negative 0.475, 0.225, when x is equal to 1.395, y is equal to 1.395 and 395. Let's see, it should be about nearly 2, so 1.9, yep. So I get a lot. Y is equal to negative 2.504, 0.557 and 1.947. So from B on graph, closest y is 1.947, therefore 1.395 and 1.947. wants to turn the coordinates. Oh wait, it just wants point. Point A. Okay. What A is from graph. I'll say that this one is A and then this one is B. From graph, that is that one, and that is that one. Okay, I didn't need to do B. Whoopsies. So using the correct technique, Olympic ski jumpers can slow the descent by creating left downward gravity. These jumpers must land successfully to have their distance recorded and land on sloped ground to prevent serious injury. A skier begins his descent at point B, accelerating down the ramp at the end, traveling horizontally at point E at 32 meters per second. T equals the number of seconds in flight after E, the height of the skier above the horizontal ground, and X is equal to that. The sloped ground for the landing, like that. Skiers suit and skis decrease the horizontal velocity, so that is that. Show that X of T is equal to that. Okay. So X of T is equal to the antiderivative of 32 minus, oh no, it's 32e negative 0.05t dt. So this would be 32 divided by negative 0.05 times 20, so yep. So it's going to be negative 640e 0.05 t plus c. Now x of 0 is the horizontal position of the skier in meters. And it's after point E. So x of t is x of 0, sorry, is equal to 100. So therefore 100 equal to negative 640 plus C is equal to 740. So then x of t is equal to 740 minus 640e negative 0.05t. It is found that the expression for the position vector of the skier in flight calculate the height of the skier above the slope at 3 seconds after flight correct to the nearest point. Okay. So then R of t, let's say R of 3 is equal to, so let's do 740 minus 640e negative 0.05x. Oh, wait. Times 3, so that's going to be 189. 189.15. And then 120 minus 2.53 squared is 97.5. And then so we'll say slope. What do they call this? Sloped ground at x equals 189.15. So wait, hold on, at x equals that, sloped ground. Maybe I'll say y of sloped ground is equal to 170 minus a half of x, so 189.15. So there's going to be the height of the sloped ground at that point, which was 75.425 meters. Therefore, delta H is equal to 97.5 minus 75.425. 97.5 minus 75.425, which is 22.075. and it wants it to the 2 decimal places, so 08 meters. Okay, determine the vertical lift provided by the ski suit equipment descent if d squared h S is a constant. Determine the vertical lift provided by the ski suit. This is HDT. So let's say h of t, let's say that's 120 minus 2.5 t squared. So then h dash of t is going to be equal to negative 5t. And acceleration is going to equal negative 5. Negative 5, so negative 5 is going to equal s minus 9.8. S is going to equal 4.8. Is that right? I think that's right. It can be shown that the Cartesian equation for the skier's flight is given by that. Calculate the time taken for the skier to land on the sloped ground, correct to the nearest 0.1 second. So do I just equal that to the other thing? Oh wait, this is the last page. Nice. I thought I was gonna have to do this for a bit longer. So if I make that equal to the y sloped, then I can find my x, and then I can find how long it takes me to get to that x. So let's say 120 minus half of x is going to equal, sorry, that's 170 minus half of x. Minus half of x is going to equal 120 minus 1000 of ln of 740 minus x on 640, and this is all squared. So then x is equal to equals 0.5x equals 120 minus 1000 of ln of 740 minus x on 640 squared. Hopefully this doesn't take long to calculate. So then x is either equal to 100 or 255.92. At x equals 100 is start of jump. Therefore ignore. Thus they will collide at 255.92. So then x of t is equal to, so let's solve that 255.92 is equal to 740 minus 640. I'm surprised I remember this. Negative 0.05t. Cast again, t is equal to negative 0.05x. So 5.58 seconds. Okay, calculate the angle at which the skier impacts the sloped ground, correct to the nearest 0.1 degree. So do I have to find the velocity at that point? Impacts the sloped ground. I think it's the velocity. So let's say v of t is going to equal 32e to negative t and then negative 5t. So 32 negative 0.05t, and then this is negative 5t, and then v of 5.584 is going to equal 32e negative 0.5 times 5.584, and then negative 5 times 5.584. This is 24.20 and negative 27.92. So let's draw my triangle. Bada bing. Like that. Impacts the sloped ground. Do I want this triangle or do I want the of? Is it going to be this theta? It's going to be this theta, because that'll be that. Wait, no, it won't. This isn't even vertical, is it? It'll be like that. Calculate the angle at which the skier impacts the sloped ground. I guess it would be that one. So this is theta, and then this is 24.20 and 27.92. 10 negative 1, and I want it in degrees. So 27.92 all over 24.2, which is equal to, this in degrees. Trig tangent negative 1, 27.92 divided by 24.2, equal to 49.08 degrees. Okay. I want to fix up this question because this will be plus or minus. So let's graph this. Graph. I want to do the positive version of square root of x squared on 2 minus x plus 1 on 4. And we take this and we do the minus version of it. And we see what we get. Solution kind of has that. Oh my god. Solution curve that contains the point. Minus x over 4, 0 and 0.5, therefore y greater than 0. For y is going to be the positive version. Minus square root of 2 on 2, so it'll be only the 0 to 9 version. Wait. God damn it, what is happening? Solve square root of x squared on 2 minus x plus 4. Let's give both. Because when I graphed it, the positive version, so it has two graphs. Let's say that's the positive version and this is the negative version. So I guess I have to graph this right hand side as well, because it's part of the curve, or it's part of the equation. So I guess I'll graph it. So it goes 1.7 non-black. Oh wait, hold on, there we go. So 1.707, so that's 1.5775. Leave up there. Okay, something like that. Oh god, I'm not sure if I'm going to lose marks for that. Y is greater than that. Part of the slope field. Or do I just stick with this top one, the y squared one? I don't know. Oh my god. I'm just gonna do the full thing. Y squared, y squared, y squared. Y squared. Okay. So solve y squared equals square root 2 minus x plus 1 or 1 4. I want my x to be 0. And then this could be 0.5. So maybe something like this. And you continue down. And here, I guess it'll also continue down. Oh god. For the solution curve that contains that point. 0.5. Like, I'm not sure if they consider this as containing, it's like the same solution curve or not. I'm not sure about it. I'm not sure. Okay, well, let's see anything else. So let's see, Z1 is 2 cis of 10 pi on 12, so yep. Negative square root of 2, and then a half, so 2, iz squared, so 1, 2, 3, 4, 5, 6. Because a quarter of pi on 2 of pi, so add pi on 6, and this is negative 5 pi, so yep. Let's see, pi on 6, which is this guy, that's 2 pi on 12. It's going to be 5 pi on 12, so it has to be greater than, yep, argument of z. And then z minus 1 has to be that, okay. Has to be less than 2. Okay. determine the values of a and n. So n is, so 60, my period, must equal 2 pi over n. So n divided by 60. And then my maximum velocity is going to equal the value of a times n, pi 30 a must be 15. Determine the horizontal acceleration, correct name is 0.01, when the horizontal displacement is 10 meters. So a is equal to negative n squared, and n was pi 30, so pi squared of 900x. Negative pi squared, negative pi squared on 90 is 1, yeah. Expression for the volume. This was a bit annoying, but yeah. Calculate probability. Okay, I think I'm gonna end it here because it's about 11:30 and I want to go to sleep. So if I lose any marks, oh well, so be it. Oh yeah. Actually, wait a minute. This one. Let me point to, I think we point to. Sample deviation is 0.3. Two times 1, 2, 3, 4. 0.2 plus 0.175 plus 0.15, 0.1, 0.75, 0.5. Like that's roughly, that's about 1 part. So if we count up the squares, I don't know, 0.9? Like, oh, so I do a normal CDF from 2.5 to 3.5 90%. So maybe I do this as 0.9. I don't know. Okay, yeah, I'm gonna end it here now. So we'll come back for marking later. Welcome back, everyone. Just finished marking. We got 91.5%, which is pretty good. Not too bad. We lost 4 marks in calculator free, and then we lost 8 in calculator assumed. So if we go through them, let's have a look at what we messed up. Here we lost 2 marks because, I mean, it's just, this was just very silly. F of 0 is not just 1.5, negative 1.5. Even though that's like exactly what it looks like on the graph, it is actually, you had to sub in 0 for there, so it would be 2 minus 2 squared root of 3, which is negative 1.464. So yeah, I just got that wrong. And then determine the domain for function. That's all good. Graph was alright. So that's 2 marks gone. We lost 1 mark here because you didn't. 43 isn't actually in there because it's n minus 1 because one of them is 0. So I lost 1 mark there, and I lost 1 mark here just for my explanation, because it would be w to the power 47 is never an even multiplier of pi, so then hence the root is not the same as that. But I got 1 mark for stating this, even though again that was supposed to say 47, but the integers or the values for k this time weren't part of the marking key, so I gave myself the mark for this. And I also gave my mark for saying 1 root will be shared, which is minus 0. And then everything else here was fine. Very nice. Here they had a different thing talking about the symmetry. Yeah, I was a bit confused on what that was. I think my one makes a bit more sense, so yeah. Okay, we're gonna go to calculator assumed now. Okay, into calculator assumed, again we lost 8 marks. So we lost our first mark here because I solved this for the wrong thing. I must have solved this for, because you needed to solve that tan of theta equals 2, but I must have solved that it was 1 on 2 accidentally, so yeah. Just because then x is 100 divided by 15 is obviously 2. So I knocked 1 mark off, but I gave myself follow through for just solving it incorrectly. This was good. Here, this was a bit odd to mark because they didn't draw this section, but there was no mark saying that like you only had to draw one of the sections. So I mean, I drew everything fine for this curve. It's just I drew extra here, so I'm not sure if I would get marked down for that because it's not specifically in the marking key that you can't do that. So I gave myself the marks. Complex number stuff was pretty good. Simple harmonic motion here was a bit silly. They actually wanted me to like evaluate this evaluate this integral. So I lost 2 marks here, but I got a mark for, I think, rearranging this or something, and then 1 mark for writing that. But yeah, you had to evaluate it, which I mean, yeah, that makes sense, I guess. Because it doesn't say an integral. I lost 1 mark here. First of all, I made a little error. I wrote x instead of a, but I'm not sure if I should knock a mark off. But you had to say that there were many solutions possible, rather than just stating the obvious like that. With the equations, you have to show that that means that there are many solutions possible. Here, one thing I could have said better was to say they were identical planes rather than overlapping in parallel. I think they are like kind of, if they're overlapping in parallel, they have to be identical. So yeah, kind of, I don't know. I think that would have been fine for the marking key. Even here I said since they're equal, so I don't know. And then everything else was good. It was pretty well done. This they actually wanted me to include the like where it starts from and then say it's a lambda, like it's a line. I just thought that b to t, like what vector is that, rather than like giving it as a line equation. So alright, I lost a mark there. Here, I don't know what I was thinking because it's clearly C is smaller. I don't know why I wrote D. So that's just silly by me. So I lost a mark there. Down here was pretty good. And then I think all of these were, oh no, the very bottom one where you had to find the angle of impact was a bit off because you had to take this value, or the 49 is taken away from the value that the sloped ground makes. So yeah. So you have to take away negative or tan negative 1 of 0.5 because that's like 0.5 and that'd be 1. So you take it away from that angle since you're coming in like this. So yeah. But all in all, 91.5%, which is decent. I'll take that in the WACE. Anything above, because my average is a 90 in spec. I wish it was higher, but it's a 90. So anything above a 90 in WACE or in these practice exams, I'm pretty happy with. So yeah, we're going to move on to 2022 now. Only 2 more exams to do. Let's go.